action. All right. I think you're supposed to edit those out, but I don't know. All right, so this is what we're doing today. Like I said, for the people joining us via video, on previous days, like Monday, the in-person video, which is ironic that I'm showing you how to watch the video from the class on the video from this class.
Oh, I get it.
But this is where you could watch the live video or the video from the recording of the class, which is kind of weird because you're watching it. Anyway, moving on. Today, in person, we are going to be doing some of these things. So I want to spend a little bit of time talking about position versus time graphs, and remind you hopefully of a few things, because I'm going to have you take a little quiz to see kind of where you're at. So when we talk about position versus time graph, a position versus time graph is just like, if this is a position of 0, how far away am I physically from that position point? So I might be 2 meters away. If I step closer, then I would go closer to the 0 mark. If I went like further away, I'd be further away. Okay, so when we look at position versus time, a lot of times we use displacement versus time. It could kind of be an interchangeable way that we could say that. We would go through, and we can talk about position versus time graph. And the thing I want you to remember, that when we talk about position versus time, we're talking about change in position. So we're really talking about displacement by our change in our time. So displacement versus time is velocity. So the slope of a position versus time graph is going to give us the velocity of that graph. Now, we can kind of qualitatively, I believe would be the way you describe it, we could just say, hey, look, this is going up, it's positive, it's moving in the positive direction because it has a positive slope, therefore it has a positive velocity. And remember, positive velocity just means it's moving this way, a negative velocity just simply means it's moving this way. An acceleration that's positive means it's accelerating that way. Positive acceleration means it's moving that way. That's all it tells us is the positive and negative tells me the direction, nothing more. It's just instead of saying like east and west or right and left is positive and negative. So this is a positive slope, therefore a positive velocity, which means it's moving in the positive direction. If we're talking about the x direction, it's moving to the right. But what we could do is we could actually put numbers in these. Now, these graphs don't have numbers in there yet. We'll get to that piece down the road. But if we started at a position of 2, at 1 second, the object is 2 meters away. And then at 4 seconds, it's 3 meters away. We can do better than just saying it's a positive velocity, it's moving that way, it's a straight line. We can actually go through and say, well, slope is rise over run. So it went from 2, it went up 2, and it went over a run of 2. So we can say a rise of 2, run of 2, or we can say it's a 1 meter per second. The slope we can actually calculate from, we can calculate the velocity from the slope of the line. Now, some of these graphs we got a little, so this is position versus time. What does the slope of a position versus time graph give us? Velocity. What kind of slope is this?
Looks like a positive one.
Positive. Is it straight or curved?
Looks pretty straight.
So does that mean my slope is constant or changing?
Constant.
It's constant, right? So if we have a positive constant slope, then we can also say our velocity is positive and constant. Now when we talk about constant velocity, well, sorry, you couldn't see that. There we go. That was the line we were just talking about. When we talk about velocity being constant or not constant or constant or changing, this might be something you want to jot down. If your velocity is constant, we could say our acceleration is 0. If your acceleration is 0, we could say that it is not, there is no acceleration, or it is not accelerating. But if this statement is true, then this statement is true. If this statement is true, this statement is true. If one of these 3 statements is true, all of those 3 statements are true. So in that graph, we said the velocity was constant because it was a constant slope. That means my acceleration is 0, my velocity, or there is no acceleration. Or you could say that because there is no acceleration, my velocity is constant. Either way you want to think about it. Okay. Now, if we go through and we say, what about a line that looks like this? Well, is that a positive or negative slope? Positive. Is it a constant slope or a changing slope?
Changing slope.
It's a changing slope, right? So we could say that my slope is positive, so therefore my velocity is positive. We could say my slope is changing, therefore my velocity is changing. Now, what does a velocity is changing mean? Velocity is changing means that your acceleration is not zero. It's some other number besides it, which means it is accelerating somehow in some direction. Okay? Now, people struggled, I think, a little bit when we started doing this, is how do we determine that this thing is speeding up or slowing down? And the idea is if we were to draw a slope of some portion of that graph, okay, we were to draw some slope of some small portion of that graph. We'd say, well, that slope is a positive slope, and we could make up an arbitrary number, and we could say, well, that is a positive slope of 8 meters per second. And make up an 8, but it's positive, we know that. Now, if we were to go through as time progresses, and we were to say, well, what's the slope say right there? Well, is that a positive or negative slope? It's still positive. Is the number bigger or smaller than 8? Is this a bigger slope or a smaller slope than this blue line? Smaller. So we could just say it's positive 6 meters per second. If something goes from 8 miles per hour to 6 miles per hour, we can all pretty much say, well, that thing's slowing down. If it gets flatter, it slows down. Now, this is saying it's slowing down in the positive direction. So positive direction means it's slowing down while going to the right, or it's slowing down while moving up, depending if we're talking about X or Y. If we flip this, the curved lines tend to give people the issues. Let's see, how do I want to draw this? I want to go, nope, that's positive slope. I want that one. Okay? So tell me about that slope.
It's not constant.
It's not constant, and it is positive or negative?
It's
Negative, okay? So this is a negative slope that is changing. If we were to draw that line, what's the slope of that line? Make a number up. Negative what?
2.
2, okay? That's a negative 2 slope. What is the slope of that made up line?
-4.
Negative 4. So what is this thing doing? Speeding up or slowing down? And before we answer that, let me try to give you a guiding question. I don't know if this is a suggestion. The number I just underlined is the speed of the object. Ignore the negative for a moment. It's telling you the speed. So the speed went from 2 meters per second to 4 meters per second. What is that object doing, speeding up or slowing down? It went from 2 to 4. Ignore the, it's speeding up, right? What do these tell us? They tell us the direction, and the direction only. Now, we can say -2, -4, or we could say 2 meters to the left. We could say 4 meters to the left. This negative tells me the direction. So it's speeding up. It went from 2 meters per second to 4 meters per second. It was going 2 meters per second to the left. Now it's going 4 meters per second to the left. It's speeding up in the negative direction. It's not decelerating. Get that term out of your physics vocab. We don't use it. It's speeding up in the negative direction. Just because it's speeding up in the negative direction, it's accelerating. If we slow down, we're accelerating. Accelerating just means change in velocity. Any other questions I can answer on position versus time graphs? Okay, then what I'd like you to do is one of the 2 pieces of paper you grabbed in the back says Progress Quiz 2.0. If you don't have the paper copy, the link for the PDF version of Progress Quiz 2.0 is posted on Canvas as well. I want you to take, I don't know, 5 minutes, however long it takes you to answer the series of questions. They shouldn't take you too long, I would assume. I would like you to first try to do it with no referencing of this page. I'd like you to try it first without using your red piece of paper with your if-thens. After you go through, or if you absolutely get stuck and you say, I don't know, then use this as a reference. But I'd like to see what you can do without this first. Okay, so take a couple minutes. Once you finish, then pull out that red sheet, cross-reference, make sure you have these things straight in your mind, and then we'll go through it together. So, for graph number 1, remember that for all, well, let's rephrase it. For all of these graphs, we are talking about position versus time graph. The slope of a position versus time graph, you just need to know is velocity. The slope tells you the velocity. If it's a positive slope, positive velocity. If it's a negative slope, negative velocity. If it's a constant slope, it's constant velocity. If it's a changing slope, okay, right? So the idea is slope is velocity. They're interchangeable words, really. So this tells you velocity. Is the object moving? The answer is no, and the reason is this is some position, and I don't know what that position is. It might be 5 meters, it might be 10 meters, it doesn't matter. It's some distance away from some starting position. The wall is 0, I'm at 2, I'm at 2, I'm at 2, I'm at 2, I'm at 2. My position didn't change, therefore I didn't move. That's one way you can determine that you didn't move. The other way to determine whether the object is moving is kind of using these next pieces. Is we could say, what is the slope? Is it positive, negative, or 0? Flat line, 0 slope. Slope is constant or changing. Flat line, straight line. Let me rephrase it. Straight line, therefore, slope is constant. Because slope means velocity, if the slope is 0, that means my velocity is 0. If my slope is constant, that means my velocity is constant. Then, again, if we use this kind of saying right here, that statement that maybe you want to hit pause and write down in your notebook if you haven't already. See, I'm recording. See, so yeah. Okay, but because my velocity is constant, that tells me my acceleration is 0 or the object is not accelerating. So therefore, there is no change in speed. We don't have to answer that question. The next one, is that a positive or negative velocity? Is it a positive or negative slope? Let's maybe start there. Negative slope. Is it a constant slope or a changing slope? It's constant, right? It's a straight line. So slope tells me velocity. Is this object moving? The answer is yes. We know it's moving. 2 reasons. One, it started at, say, some distance, say 5 meters away. Now it's at 1 meter away. It went from 5 meters to 1 meter. It moved. Or you can say, well, slope means velocity, and there is a slope. Therefore, there is a velocity, which means it's moving, right? If there is because velocity is not 0, then the object is moving. But the slope is negative, which means my velocity is negative. The slope is constant, which means my velocity is constant, which means my object is not accelerating. Okay, now this is a curved one. Sometimes people struggle a little bit more with curved ones. The ideas are similar. Slope gives me velocity. Is this a positive slope or a negative slope?
Wait, what?
Is my line going up or down? Is it a positive slope or a negative slope? It's negative, right? It's going down, so it's a negative slope. So because it's a negative slope, it means we have a negative velocity. And all that means is moving in the negative direction. It's moving to the left. That's what that negative means, the direction of motion. It's moving in the negative direction. My line is, the slope is changing, therefore my velocity is changing. And because my velocity is changing, it means my acceleration is not equal to 0, or we could say the object is accelerating, or we could say the object, is it accelerating? Yes. Speeding up or slowing down. Now this is the one that you have to kind of go through, and this is where you kind of draw those like tangent lines. And you say, well, the slope was here. I don't know if that shows up well. Okay, it was here, now it's here, now it's here, now it's here. It still is going, it is negative, but it was flatter and it's getting steeper, which means my slope is getting bigger, and the slope, the number of the slope tells me speed. So if the line is getting steeper, it's speeding up. The fact that it's negative simply means it's speeding up in the negative direction. That's all that tells us. Okay, last graph, number 4. Again, it's a curved line. Sure. It's a curved line, so the slope gives me velocity. The slope tells me the velocity. The fact that there is a velocity means that the object is moving. It's changed position, so it moved. It's a negative slope, which means negative velocity. It's a curved line, so therefore my slope is changing, which means my velocity is changing. Because my velocity is changing my object, yes, it is accelerating. Now this one, the slope was here, now it's here, now it's here, now it's here. It's getting flatter, so my slope is getting smaller. So I went from like -8 to -4 to -2 to -1. My number is getting smaller, therefore it's slowing down. It just happens to be slowing down in the negative direction. Missed with a fly. All right, questions on that? Okay, then I'm going to try to keep this moving kind of reasonably paced, hopefully. I want you to pull out 2 things. I want you to pull out, oops, that's the progress group. Pull out your motion graphs, the position versus time graphs, numbers 1 through 9. However, now we're going to flip it over to letters A through I. And then your sheet is red. It says velocity versus, or position versus time. Flip it over. And today we're going to fill out the velocity versus time graph. Okay, so what I would suggest, is right on the top of the velocity versus time graph, say slope, there should probably be an arrow. Slope gives us acceleration. Just like I did on top of the graphs themselves. Slope is going to tell me acceleration. Okay, now these are different. Okay, these are something that we call velocity versus time graph. These are not position versus time. These are velocity versus time. It's a mental brain switch. You have to say slope means something different. You're looking for different things, but you can still come up with a lot of the same questions. So here we have velocity on the y-axis and time on the x. If we all kind of go with the convention that this line down the middle is 0, this is 0 velocity, this is positive numbers getting bigger, this is 0, this is negative numbers getting bigger. Okay? Now if we talk about the slope of a line, the slope of some line, it's rise over run, it's my change in velocity. The change in velocity divided by a change in time, by definition, a change in velocity is an acceleration. So the slope of a velocity versus time graph is going to tell us the acceleration of this object. So how do we determine if the object is moving? How do we determine if the velocity is 0? Well, velocity is directly on the y-axis. So we are looking for a line that would have a value of 0, not crossing only at one point of 0, but it has a value of 0. So when we say, how do we know if the object is moving or if the velocity is 0, it's going to be on the 0 velocity. It's going to have a value of 0 on the y-axis, which is kind of hard to see, but I drew like a red line here. Which graph, A through I, has a velocity of 0 on your 9 of them?
Oh, maybe the last one.
Yeah, it's the last one. It's letter I, right? And I'll move that right there.
Yeah.
There, it's the value is there. There is no velocity, okay? So that's what we're looking for. So to answer kind of that same question that is this object moving? The object's moving if it has a velocity, but if there is no velocity, it's not moving. Okay, so that's how we know if its velocity is 0 or if it's stationary. How do we know if it's positive? Well, again, velocity is directly on our y-axis. So if we have a value that's above the 0 line, that's a positive velocity. It goes positive 1, positive 2, positive 3, positive 4 as we go up. So it has a value that's above that 0 mark. These three graphs are all examples that have a value above the 0 mark. Now, some of them have no slope, some of them have a positive slope, some of them have a negative slope, but they're all above that positive line, which means they all have a positive velocity. What does a positive velocity mean? It does not mean speeding up or slowing down. It means it's moving in the positive direction. It's moving to the right. It's moving up. It's moving in a positive direction. That's what a positive velocity tells us. So this is starting at 0 and going to like positive 3. This is at positive 2 and it's staying at positive 2. This starts at positive 3 and it goes to positive 1. I'm making numbers up. We're looking for general trends. These are all positive velocities because they're all above the 0 mark. So similar kind of rationale. How do we know if it's a negative velocity? Well, we're going to be below that line. Okay, so we have our velocity line, our data is below the 0 mark. That's how we know if we have negative velocity. Now, what does a negative velocity mean? It doesn't mean speeding up, it doesn't mean slowing down, it doesn't mean like physically backing up. It means I'm moving in the negative direction. If we're talking the x direction, it's moving to the left. If we're talking about the y direction, by convention, we're talking about things moving downward. Now, this dark line, one of these three statements is true. In every motion graph, every velocity verse, one of these three, and only one of these three statements is true. And there's a line, and there's like another subset of questions, and one of those statements, and only one of those statements can be true. Okay, so how do we know if the velocity is constant? Well, remember, constant velocity means my acceleration is 0, and the slope of my line tells me acceleration. So if my slope is 0, my acceleration is 0, which then means my velocity is constant. Or we could say this is 2 meters per second. Now it's 2 meters per second, and it's 2 meters per second. We could physically make up numbers and say, well, that's 2, 2, 2, 2. Hey, my velocity isn't changing. My velocity is constant. -2, -2, -2, or 0, 0, 0. Those are all examples of velocities that are constant. The slope is 0, which means my acceleration is 0, which means my velocity is constant. Or we physically make up numbers. Doesn't matter what numbers we make up, we just kind of got to follow certain trends. So no acceleration happens when there's no slope. Slope is 0, means acceleration is 0. Acceleration 0 means your velocity is constant. So a slope that is not equal to 0, remember slope tells us acceleration. A slope that's not equal to 0 means my acceleration is not equal to 0, which means my object is accelerating. Or we could say my velocity is changing. One of those three statements. If one of those statements on the board is true, all of those statements on the board are true. Okay. Now, it has some slope. It doesn't matter whether there's a positive slope or negative, there is a slope. It's not 0. It doesn't matter if it's a really big slope or a really small slope. It's just not a 0 slope. It's not flat. It's anything but flat. It could be positive, could be negative, and it could be a negative. There's another one too, but it could be a positive above the 0 with a positive slope. It could be above the 0 velocity with a negative slope. Or the other way too. This is what is it? Negative velocity, negative slope, negative velocity, positive slope. Those are the kind of 4 choices. This is just telling you it is accelerating. The fact that is making the statement that it is. Now, the statement on the board that says if your velocity is constant, there is no acceleration, or acceleration is 0. My velocity is constant, my acceleration is 0, which means my object is not accelerating. And remember, the slope of a velocity versus time graph tells me acceleration. So my acceleration is 0, that's because my slope is 0. A slope of 0 is a flat line or horizontal line. Okay, it could be a positive velocity with no slope. It could be a negative velocity with no slope. Or, I can't quite see it, but it's a 0 velocity with no slope. It's just flat line right on the origin. If acceleration is 0, velocity is constant. Velocity is constant, acceleration is 0. If one of these statements on the board is true, all the statements on the board are true. Let me clarify that. In a given line. If one statement in a line is true, then all statements in that line is true. Acceleration is determined by slope. Acceleration is determined by slope. So acceleration is not 0, means it has a slope. That's all it means. Is there some slope? Acceleration is not 0. It's not 0. It's not 0. It's anything but 0. Because acceleration is determined by the slope. In a velocity versus time graph, if we have a positive acceleration, it's got to be a positive slope. Or we could say the graph is going up. The line is going up. If my acceleration is not 0 and negative, slope tells me acceleration. So a negative acceleration means a negative slope. In a velocity versus time graph, acceleration and slope are interchangeable. In a position versus time graph, slope and velocity are interchangeable. They're two different things. It's kind of it takes some practice. It's a mind shift. You have to say, nope, velocity, the slope of velocity is acceleration. Velocity versus time is acceleration. Position versus time, oh shoot, velocity. Slope is velocity, okay? So we kind of you have to make a mental shift. You gotta kind of change gears. So you should be able to pick one of those. Now, that's kind of a lot, but whatever. I'm just gonna uncover it all. If your speed is the same, your acceleration is 0, which means your velocity was constant. I don't think the video got really expressed, showed how high I jumped there. So I'll do it again. Speed is the same, your acceleration is 0, which means your velocity is constant. Yeah. I don't think the video didn't quite do it justice, just for the record. My mom. Yeah, my mom's like, I really think you should go into non-sports. I don't know if you could tell, but I wasn't that athletic in high school or any time in life. It's okay. Come to terms with it. So if our object speed is staying the same, that means my acceleration was 0, which means my velocity was constant. So how do we know if my object speed is staying the same? Well, it's not going to accelerate, therefore my slope is 0. We're looking for flat lines. We're looking for the same 3 things here as we did here, as we did up there for velocity is constant. Those 3 things are exactly the same. If one of those is true, all 3 of those in motion graphs is true. So acceleration is not 0, means the object is accelerating. But now we have to determine whether it's speeding up or slowing down. And these are not directly correlated together. So how do we know if an object is slowing down? Well, the slope has to be not 0 because it has to be accelerating. The speed has to be changing, velocity has to be changing, therefore it's not 0, which means it is accelerating. So both of those statements are true. The slope must not be 0, the slope must not be 0. And, okay, the 2 things, has to have a slope and if we're looking for something that's slowing down, it physically needs to be getting closer to our velocity of 0. It has to be approaching the 0 mark. So this is a positive velocity that's getting closer to 0. That's slowing down. This graph is a negative velocity because it's below the line, and it's getting closer to 0. It's getting closer to 0, which means the speed is slowing down. But it's negative, you're right. It went from -5 to -4 to -3 to -2 to 0. It slowed down. The negative tells me the direction. Then the opposite is true when things are speeding up. They're getting further from the 0 mark. This is getting further away in the positive direction. This is getting further away in the negative. The negative and positive tells me the direction. Another way to think about these two is if my velocity and acceleration are in opposite directions, it's going to slow down. My velocity and acceleration are in the same direction, it's going to speed up. So think about it this way. If I'm driving my car this way, and I accelerate this way, what happens to my speed?
Wait, what?
I'm driving this way, I accelerate this way in my car, what happens to my speed? I go faster, right? I'm speeding up. What if I'm driving this way, and I accelerate this way, what happens to my speed?
You're still speeding up.
I'm speeding up. I just happen to be speeding up in the negative direction, right? I'm speeding up. My fingers are pointing in the same velocity and acceleration. Now, what if I'm driving this way, but I accelerate this way?
By going reverse. Kinda.
If I'm driving this way,
Yeah.
and I'm accelerating this way, remember, we don't use the term decelerate. If I'm driving forward, my velocity is in the negative direction, but I accelerate this way, what's true about my speed? It's slowing down. If I'm driving this way, and I'm accelerating this way, I'm slowing down. If they're in the same direction, I speed up. If they're in opposite directions, I slow down. Okay? I'll leave that up for just a moment. I want to talk about your virtual days coming up here. You have 2. The other handout you picked up on the way in is velocity versus time graph questions. The velocity versus time graph questions refer to the graphs that are lettered A through I. Okay? The graphs that are lettered A through I. That's one thing. I want you to take a picture. There's 3 pages. Make sure you include all 3 pages. Yes, the answers are posted on page 3. The other thing, and I'm still working on the instructions here, because I'm still figuring this out. Can I switch this? We good? Okay, I have a game that I'm gonna have you play.
I like games.
Don't tell the other teachers. But I found this game, and it's called Motion Mapper. So it's kind of a game. We'll call it a game. Okay, so what you want to do is if you open the game, and they'll be linked, they'll open up this. And now there's different things you can do. We are only going to focus on the horizontal axis. Don't worry about vertical, and we're only going to do position versus time. We're only going to do position versus time, and we're only going to do horizontal axis. However, there are 2 modes, and I want to make sure I show you both modes. So we want position versus time, and we were in what they call the control mode. So on the bottom here, is your little block that you change your position. So you need to get your position to be, and it's way easier on an iPad, by the way. Hey, I got that one right. So now my position is going to change. Ooh, I failed.
Why did you fail?
Because I got to stay in the green. Okay, so I got to drag my block. I ran out of mouse space. That's a bad excuse. Okay, now you can actually go through, and if you want, you can change your game speed down, which is good and bad.
Wouldn't that make it not fun?
Now that's not the smoothest constant velocity, but it accomplished the task. Now, when you're done, if you go back, it will say, hey, I got 3 out of the 10 vertical positions right. You got to get 10 out of 10 of the horizontal position versus time graph. The other thing is there's an input mode, and I want you to do velocity, position versus time. But now what you can do is you can go through and say, hey, I need a position of 2 meters, because that's in the green block, and I need a velocity that's going to match. This is a position versus time, So we're looking for slope. Remember, we can calculate slope by rise over run. So I had no slope, which means I had no velocity. But now for something like this, it changes velocity. So at time, this is a drag box, at 2 seconds, we want to set our velocity to whatever the slope of this section is. So you have to go through and calculate. It starts at 2 and it ends at 6, so it goes, wait, 6? Yeah, so it goes up 3, no, starts at 2, goes to 6, so it goes up 4 over 2. So it's going to have a positive velocity. At 2 seconds, you're going to set the velocity to 2. Come on. Wahoo. Okay. Yay. Thank you. Okay, and then when you're all done, you get through, there's 10 modes there. We can go progress report. And I want a screenshot of this. Now, you're going to type your name, and you can't change your name once you enter it. And it even seems to, it's like a cookie thing, I think. Type your name in, hit enter, and I'm looking for this to be a 10 out of 10, and I'm looking for this one to be a 10 out of 10. And I'll put some screenshots to try to show you, like, this is what I want, 10 out of 10. I want your name, 10 out of 10 on those two. Only the horizontal motion, and only the control mode and input mode for the position versus time. Okay, one screenshot. With that, we'll have your name and everything on there. So, questions on that? I'll get some screenshots to clarify all that. So, it does work on an iPad. I just tried it earlier. And it is easier to do that drag one from there. Okay, so let me know if you have any questions. Otherwise, see you guys on Monday. Wipe your desk down on the way out. Greatly appreciate it.
Time to go make money.
I should turn off my video.
I'm gonna go sell my Xbox controllers on current.